This video about data representation is relating to hexadecimal. If you don't know what binary is or how to convert from binary into normal denary numbers, then you need to watch that video first. Hexadecimal is just another number system that we use in computer science. It's basically a combination of digits and letters to represent a number. They're much shorter than using a full binary string. So an example where you might have seen them used is for color codes in graphics and on the web. For example, in this image at the bottom, you can see that FF0000 in hexadecimal color code is the same as 1111111000000000 in binary. It's much quicker and easier to say FF and 4 zeros. It makes the whole number system a little bit quicker and easier, and sometimes people remember them slightly better when there's letters used. Hexadecimal is sometimes also known as base 16. The reason for this is because it's got 16 different digits. A single hex character can represent any denary number from 0 to 15. That means there's 16 different options. This would require 4 bits of binary code to make up one particular character. Each hex character is a nibble in binary. This table should make things really easy and clear to see how it relates with hexadecimal to denary and binary. You can see that the normal everyday numbers that we use in denary count from 0 down to 7 on the left and then continue from 8 to 15. Next to it is the hex value, so exactly the same as denary all the way down to 7, 8 and 9. However, when we get to 10, it swaps over to a letter system. So 10 is equal to A, 11B, 12C, 13D, 14E, 15F. And then next to that you can see just the normal counting of binary from 0 all the way up to 15. So as always, you might be asked to explain why we use something. So why do we use hexadecimal? It's much simpler to remember large numbers in hex than it is in binary because they're much shorter. There's also less chance of you inputting something slightly wrong. It's also much easier to convert from binary to hex. So this is like one of the dead cert questions that you're going to get on your exam. You're always going to have to do some sort of conversions between hex, binary and denary. So in hex, if you move from right to left, you basically place values increasing in powers of 16. So in order to convert from hex to denary, what we've got to do is draw up a little table, and you fill in the boxes and then you multiply and add up all of the results. So right now you're probably thinking, I haven't got a clue what you're talking about. But on the next slide, you'll see examples. Once you've gone through the examples, it's really, really easy. Okay, so we're quite lucky in the sense that you're only ever really going to need to do 2-digit hexadecimal numbers. So all we need to do is draw a really simple small table that goes 1 to 16, goes up in powers of 16, but we don't need to go any greater than 16, so you just got a little 4-cell table drawn out. So you're always going to draw a table with 16 and 1 in the top. Underneath that are where the values are going to be different. So for this particular case, we input our number underneath. So our number is 88 in this example. We put that into the table. What we do now is we multiply the numbers together. So 8 times 16 is the first one starting from the left. 16 and 8, we multiply them together. The answer is 128. Do the same again. 8 times 1, because there's a 1 and an 8, is 8. You add the two results together, so 128 plus 8, and you get 136 as a total. So 8 in hex is 136 in denary. Let's try another example with a letter included this time. So we're going to convert the hexadecimal number 4e into denary. So we draw the exact same table again, 16 and 1. Underneath we put the first character, and then underneath the 1 we put the second character. Now what you've got to remember, this is the only really even remotely tricky bit, is that once you get to 10, 10 is equal to A, so 11 is equal to B, 12 is equal to C, 13 for D, and 14 for E. So we know that E is 14, so you put the number 14 in here. So 4 multiplied by 16, 64. 14 times by 1 is 14. So we're going to add 64 to 14, and the answer is 78. So 4E in hex is 78 in denary. Okay, so we need to learn how to convert back the other way. So we're going to convert from denary to hex. Now the table is exactly the same, however we do something slightly different. This time, for the 16 and the 1, we need to divide our original denary number by those numbers. Whatever the results are, go in the lower row, and then your final conversion is basically whatever it says in that low row. Everything is easier with examples, isn't it? So let's just look at an example here. So 106 is our denary number. We want to convert it into hexadecimal. So we draw the same table as before, 16 and 1. This time we divide 106, which is our number, by 6. And this is the key. You need to count how many times 6 goes into it. Okay, so, 16 goes into 106. So it goes in 6 times with 10 left over. So you put your 6 into the low end of the table, and then you basically put 10 in the other one. However, what we know is that 10 is actually A in hex, so we're going to put an A in instead. So 106 in denary is 6A in hex. Okay, let's look at another example. So to convert the number 57 into hexadecimal, we draw out our small table again with 16 and 1. And all we need to do is divide 57 by 16. So how many 16s go into 57? We can get up to 3, and then we have 9 as our remainder. So we put 9 in the next column along. And you can see that the final answer is 39. So 57 in denary is 39 in hex. I always think it's a good idea to have a backup plan, and I actually find it a little bit easier sometimes to convert in this format. So what you can do is you can convert from hex into denary and then into binary. So in the exam you might be asked to convert something from hex to binary. You just go through the same steps. So if we split up our hex number into 2 separate parts, so in our example here we've got 6e in hex. We want to convert that into binary, so we're going to split the hex into 2. So we've got a 6 and we've got an e. We work out what each value is in denary first, and then we convert it into binary. So we know that a 6 is just a 6 in denary. We know that e is 14 in denary. So we've got our 2 separate values. We can put them into binary. So 6 in binary is 0, 1, 1, 0. And 14 in binary is 1, 1, 1, 0. Then you work out both of them and put them together. And 6e in binary is 0, 1, 1, 0, 1, 1, 1, 0. Thanks for watching this video. I hope you found it helpful. Please like and subscribe. Bye.